All right, we're back. We are game 2005 in the fall 2017 semester. That's game physics. We're week 2, part 2 of our broadcast. We're talking about limits and derivatives. We just last left off with an example that we did together in class for a derivative. I want to take that further and do the next example. Okay, so here's the next example. 5x to 2 times e to the x. How do we find this one out? This is kind of neat and different, right? Now, it looks complex when you look at it from the first time, but let's take a look at our rules, right? So I'm going to go back. And let's just get rid of these, right? And all we care about is the original function. So we put the original function in first. So when you write your question, right, you're going to have the question text first, like this, find the derivative, right? 5 times x to the 2, right? And then multiply by e, Euler's number, right? The power of x. That's your position function, right? In this particular case, right? How do I find the first derivative? What's the first thing that I would do here? Think carefully, right? Product rule. Why is it the product rule and not that thing where we separate the, two things that are multiplied together? Why is it the product rule? Remember, we have a couple of the product rule says you take the first multiply the derivative of the second plus the second the derivative of the first times the second. That's the product rule. But remember, we also have some other identities back here, right? That said something like this, right? Constant times this. Can I use this constant multiple rule somehow? No. I can't multiply. There is no multiplication commutative value like we have in limits. It's different from limits, right? So whenever you see this, you know that there's two separate functions we have here. We have x to the 2 multiplied by a scalar 5 with another function, which is Euler's number multiplied to the x, or to the power of x, right? So going back to the graph, this is the graph, what it looks like, and that's the position function. So you can imagine an alien has some kind of weird function again on our screen, and we want to get the first derivative. What's the first derivative? Let's do the first derivative together. What's the first thing you do? Product rule, right? First, you identify that it's the product rule. Okay. Is there something that can make our lives easier? Take the 5 out, right? Because it's a constant. Remember, we can use that rule too, the constant rule, right? So let's leave the 5 out for now. Now I have two more, like a simplified functions. I have x to the 2 and e to the x. So I take the first, right, times the derivative of the second. What's the derivative of e to the x? E to the x, actually. E to the x is what the derivative is, right? Take a look at the function. If I go back to the value, any e to the x is e to the x, right? That's the identity, right? Whenever we use Euler's number, any Euler's number to the x is equal to Euler's number to the x. You don't do anything with that. You leave it as is. That makes it a lot easier for us, right? So that's the first term, if you will, right? And then we have the second term, and now we have to take the derivative of the first times the second, right? So the derivative of first is 2x, because remember we got rid of the 5, right? So 2x, right? Times e to the x again, right? Okay? And now we multiply everything by 5, right? So we could take the 5, but we've taken the 5 out, so we're just going to do one of these and do this. And that could be as simple as I want you to go, right? So that's the first derivative, right? That's the first derivative. Take a look at the curve. That's the dark curve to the right here. I'm going to bring this down so you don't have to see this anymore because we know how to do all that. Notice that this is the position curve, the red line. This is the velocity curve. It's very similar to the position curve in this particular case where it speeds up, right? Then slows down and then speeds right up again. right? It keeps speeding up and speeding up and speeding up. Different kind of velocity. Anytime you want to find the instantaneous rate of velocity at any point x, right? That's the first derivative, right? Okay, let's do the second derivative. What's the second derivative of this? What do we have to do first? Get rid of the 5 first. Put the 5 aside for a second, right? You could do that too if you really want to, but that would be, you would have 5x squared times e to the x plus 10x times e to the x, right? You could do that if you really wanted to, right? But let's leave it out for a second because it's not going to affect us, right? Because it's a scalar. All it is a scalar scaling up our curve. That's what it does, right? And that's why we can take it out. It's not going to affect us in any way, right? All right, so we have then x to the 2 multiplied by e to the x, right? Now, did we do something wrong? No. First, we take the original function, x to the 2, multiplied by e to the x, right? Because that's the first derivative, the derivative of the second function, right? Now, this is where it gets a little different. Plus, okay, 2 times x, right? 2x. So hold on a second. So we're still doing this one. There's two product rules we have to use. We have to use product rule in this one, and we have to use product rule in this one. Does that make sense? Because there's 2 parts. There's 2 different terms we got to do product rule on, right? Does everyone see that? Right? We used product rule to get us to this point, but now we have 2 terms that we have to use product rule on again, right? So let's continue with the first term. We're still doing the first term. So the first term is, now, so we've taken the derivative of the second multiplied by the first. Now we're going to take the derivative of the first multiplied by the second. Okay, and that's our first term. So I'm going to put that in brackets for you for a second, okay, just so that we see the first term. This is term number 1, all right? Plus, now we're going to do the product rule again, okay? And we're going to say, well, it's the first times the derivative of the second. Now, notice that I have 2x. Could I keep 2x like that? I could, right? I'm just being careful. I could also take it out and put it outside the brackets because it's a constant if I really wanted to. Let's leave it as if for now, just to make it easy. I'm going to multiply everything by 5 afterwards, right? Times the second, right? Right? Makes sense so far? Plus the derivative of the first, right? Multiplied by the second, by the second. Oops. And that is so far so good. And now in brackets around everything else, because we've taken the 5 out, we're going to put big brackets and put the 5 over here. Does everyone see that? Because all we're doing is carrying down that scalar, right? Because we're taking the constant out. That's all we're doing. If you expand this whole thing out, you're going to see that it's the same answer as if you expanded everything, right? Notice that there's all the curves. They're very similar. And the black curve is the acceleration curve. See how at any point x, you can find the acceleration, right, based on this formula. Are we clear? Now, this is, again, more complicated patterns, right, as opposed to that simple x to the 2, right? But you should be very clear about what I'm looking for. So when on a test, I don't want you to go further than this. I don't need you to go further than this. As long as you can prove to me you know how to do the first and second derivative, you're good to go. All right? And I'm going to put it on there. Don't simplify, right? Beyond, like, you know, leave it as this at this particular point, that first part. Because once we start simplifying, then we're going to collect like terms, and it's going to just eat up your test time. And that's just, you know, getting to the simplest form. We're not mathematicians. This works just fine for us. Okay? It bothers you, doesn't it? You want to simplify, right? Yes. I'm not going to stop you, but it's going to waste your time in a test, right? I'm not going to simplify. So if I ask you a multiple choice true false kind of question, and it's one of these, it's going to be like this, right? Is this which one is the right one, the right answer? You're unhappy with it. You want to simplify everything. I know it, Hercules. All right, here's theorem number. So we did this one. We did the product rule. Is that the same one? No, we're down. Now there's the quotient rule. Okay, now we get into some big trouble. So when do we have the quotient rule? When we have one function over another function. All right, one function over another function. And there's one rule that I'm going to be talking about, which is even more complex than that, called the chain rule, which is the most complex, right? So we've got the product rule, the quotient rule, and the chain rule. And those three, I know you're like shaking your head, no, I don't want to remember these things. You don't have to remember them. They're going to be on all the equations for all this stuff. All the identities are going to be on your test paper. So you don't have to remember. I'm going to give you the formula sheet, right? Or you're going to make one. We have to decide that as it comes time. So how do we do this? Well, what we do is when we have a quotient, so we want to find the derivative of this value. Now it's the other way around. We take the derivative of the first times the second minus the derivative of the first times the derivative of the second over the second squared, whatever the second function is. So how do we figure this one out? First of all, does everyone understand what I'm talking about here? Again, so think about this hash mark here is derivative. So we're saying take the derivative of the first term, that's f of x, right? Multiplied by the bottom. So in other words, it's derivative of the top times the bottom minus the top times the derivative of the bottom. That's what we're doing, over the bottom squared. Okay? Let's try this out together. So this is the thing we want to try it out. So let's get rid of these. Oh, sorry. Oh, let me just expand it for you so you can see it all. There we go. How's that? By the way, before we get there, what if you want to prove this is right? Is there a tool out there that can help you? And there is, right? There is a tool. If I want to find online derivative calculator, there is. There's a tool out there, no problem. That'll help you out. So let's just use this one. Here's derivative calculator with steps. I love this one. Right? That means either that it's down, right? But there's always some other one. Yay. There we go. So d over dx, and if we want to write in the derivative, right? So let's go back to the derivative, which is over here. So this is the first derivative, 5x. As I take this whole thing, hopefully it'll take it. Let's see if it takes it. So if I can type it in there and yay, and we press go, and then you can see that this is the first derivative. So we weren't wrong, right? In fact, it took the 5 out. Right? So that's how you do it. That's why I recommend you always use an online tool. It's easy to set up, even if the one was down. There's other online derivative calculators. When I give you your assignment, check your work with this, right? I'm going to give you your assignment, but I want you to try it first on your own. So I give you an assignment. I don't care if it's perfect. If you give me everything perfect on the assignment, right? What I care for is, do you understand the steps? Because on a test, you won't have this derivative calculator, right? And then you're in trouble. So do your homework. Your assignment is an opportunity for you to do your homework and then hand it in to get a good mark, right? Okay, notice it says, what's this? Right? No, I don't want to do that. That's definitely not. I don't want to subscribe. But what if I want to take the derivative of the next step? I think it actually allows you to take the next derivative if you want to. Maybe not. Oh, it even gives you the graph. Look. Wonderful. So if I want to take the next derivative, so I take this one, and it does it allow me to copy? Maybe. And if I plug it in up here, and I press go, that's the second derivative, right? And there it is. Now it expanded. That's what you wanted to do. You wanted to expand it and simplify, right? You don't have to go there, okay? But it actually shows you all the steps throughout this whole thing if you really want to. Questions around online tools and how to use them. I highly recommend them to check your work, especially when we get to the physics pieces, right? Once you get to the physics parts, you want to find as many online tools to check to see if you're right, because in real life, you'd use them anyway. You check them out. You see if you're right? So I'm going to allow it. On a test, I can't allow it because I need you to understand how to do derivatives. This is part of the first test that we're going to do, okay? Let's get back to what we're going to do, though. So let's get rid of these. And let's get to that next question that I want to try out with you guys, right? Just keeping an eye on the time. And let's see, I can't. So 3x minus 4. Let's try this out. So I'll put it in brackets. Oops, let's get rid of this first. in brackets 3x minus 4. Putting it in brackets, that way it'll give me this automatically, right? If I press slash, right? 3x minus 4 over 2x to the 2 minus 1. So 2x to the 2, right? And then, oops, minus 1, okay? That's a weird-ass graph. Take a look at this, right? See this? Hey, does this limit exist? Actually, yes, in this particular case. It's really weird. It depends on which one you're looking for, which point. Okay, let's take a look. So we've got this equation, and I want to find the derivative of this. Now, I also have to say that there's sometimes you need to do a little bit of algebra to make your life easier. Okay? Like, for example, if this was x plus 1 on the top and you had x squared minus 1 on the bottom, what would you do? Right? You'd factor it out first to make your life easier, right? That makes more sense than going through the whole process, because then the quotient rule is really long. And this is where remember I told you that you don't want to simplify because you have no time, because you have no time. You have to do all this stuff, right? And literally, when you're writing a test, you have to kind of get to the point where you know what to do. So, okay, so we're going to take the top. Let's do it. And by the way, this has a specific order. So it's the derivative of the first. You must do it in this order, right? Remember the other way didn't matter because there's a plus? This matters. So div top times bottom minus div bottom times top, right? So div top, let's try this first. So 3x times bottom, right? So 2x again to the 2 minus 1, right? Minus, did I do it right? Oh, I'll be okay. Oh, that was right. 3x div top 3, right? Div top times bottom minus div bottom, right? So 4x, right? Times top, right? Which is 3x minus 4, right? And then all over the bottom squared. So the best way to do it on this tool is take this. That's why I've learned to do it. And then divide it by the bottom squared. So you take the bottom and then multiply and square that. And that's the answer. No. Just my typing. So if you look at the blue graph, notice that it's another weird graph that comes out. So that is the derivative. Now, would you simplify? No. Look how long it would take. It would take you some time to simplify this thing, right? Why would you want to do that? Leave it alone. Now, where it gets really hairy, where things grow hair, all right, is where you want to go to the next derivative. We're not going to do that here today, only because I don't have any time. All right, once you go to the next derivative of this one, it makes sense to simplify a little bit to make your life a little easier to go to the next derivative, right? But only as little as you need to. For example, I probably wouldn't touch the bottom at all. I would leave it as is, right? And then I would take this top part, simplify it a little bit, collect like terms just a little bit, just to make my life easier, not because I need to for the answer. This is good enough for marks, right? The first mark that we talked about. But please don't simplify further than this if I only ask you for the first derivative, right? You don't need to. I know Hercules is going to go crazy, and some other people will go crazy out there. This is enough. If you went to the next level because you felt uncomfortable, you're not going to get bonus marks. I'd be okay with it, right? So Hercules, optionally, if you really want to go to the next level, go ahead, man. All right, go ahead. Yeah. It's all the power to it. Yeah. Well, that's the problem, isn't it? Isn't that the problem? Isn't that the risk you take? Huh? All right. Don't do it. That's the answer, right? That way you don't screw anything up. And when you check your work, it's going to almost look like this anyway. Okay, so let's not take it to the next level because we don't have time. I'm running out of time here. I'm timing out. And I want to get, I want to get to some other options. Here's another one. What do you do with this one? Let's do the same thing. Let's do, so we're going to get rid of this. And we're going to get rid of this, right? And let's start typing in. So we'll say 5 divided by, right, 4e to the x plus 3x, right? 4e to the x, right, plus 3x. All right, some simple examples. So that if you see, again, this is some weird graph that has no limit in the middle where x approaches 0, okay? If the limit approaches 0, is there a limit as x approaches 0? And the answer is, in this case, look, x approaches 0. We have a value where x is 0, and it can be found from both sides. So the answer is yes, the limit does exist, right? Okay, but let's go to the next level. Let's take this to the first derivative, all right? How do we do this? So div top times bottom minus div bottom times top, right? So div top, 0, times bottom, 0, right? Plus div bottom, so 4 times e to the x, guess what that is? Okay, div bottom is 4 times e to the x. What's 4 times e to the x? 4 times e to the x. Right? Does that make sense? Right? Plus 3. That be correct? You see any problems with that? Okay, and this, I'm just going to keep the 0 in there just to hold our thing, right? Now you probably, for zeros, please simplify the zeros. Take the zeros out. Over, oh yes, times 5. Did we do that already?
No, because the second issue.
Yes. Over, sorry, I'm ahead of myself. Times 4 times e to the x, right? Plus 3 to the x squared. Right? Now you'd probably get rid of the 0, right? Because the 0 doesn't make any sense, right? And notice that there's no graph, right? Whenever you have no graph like this, right? Like there's not, this the symbol says I don't understand this. Why don't we understand this problem? Because of this, right? Once I take this out and put it in front of the other thing like this it understands, right? This doesn't understand the other way around, okay? It doesn't really matter at the end of the day, right? Yes, did I make a mistake? Missing a negative?
It's a minus 5.
Is it a minus 5?
Yeah, because this is the second term.
Let's do that again.
0 minus
Let's do it again. Let's do it again. All right. So we'll leave the bottom intact, and we'll just kill this part. Okay. Let's try it again. All right. So div top, 0, right? Times the bottom, it's still 0. Minus, right? This is where the minus is. Minus div bottom, which again is 4e to the x. Hold on. Plus 3. Right? Right? So that's the bottom times 5. And this whole thing is times 5. This one, I just did the wrong way. So it'd be like this. Right? I'll put the 5 on this side this time. That make sense? And then we get rid of the 0 because we don't care about the 0. But not the minus, because we need the minus, otherwise we lose that negative, right? Does that make sense? Do we want to go for the second derivative? No, we don't. We're going to move on. Once we have Euler's number and the log functions and all those funky things, I go a little squirrely. Like my eyes just start crossing. And if my eyes cross, your eyes cross. All right, so let's just move on.
Just a quick question before you do. On the test there, does it matter then if we have the 5 at the beginning or at the end?
No, if you can move it around. I mean, yeah, as long as I see it and it's similar. I'm going to have an answer digest, right? I'm going to look at it and go, here's my key. Yep. Okay. Quick, check. What? What did they get? Oh, wait, did he simplify? Yeah, he's a simplification, right? And so then I'll say, yeah, he's simplified. That's right. So I'll have the simplified version too, just for Hercules, right? All right. Last part, derivatives of trig functions. Okay, we've already covered them when we did our first example, but here's the derivative of trig functions. So the derivative of sine x is equal to cos x. The derivative of cos x is negative sine x. It's important to know that, right? By the way, with integrals next week, I will be covering the derivative chain rule. Okay, so I'm not going to talk about chain rules this week because it's enough to like really blow your head up, right? So just take it, we'll go from there because then you have to kind of do some funky stuff, right? So please hold off until next week for that. All right, so the derivative of tan x equals sec squared x, right? Or you can also write it as sec x to the 2, same thing, right? For trigonometry, remember we talked about trigonometry last week around that. And the same thing with the other functions. And just a reminder what sine and cosine look like, right? Just because if I'm going to include anything on your test, I'm going to include these two graphs. Why would I include these two graphs? Yeah. Secant line, right? Which is the stuff that crosses the curve. Remember the line where I have the curve and it crossed both sides? It's a secant line, right? A tangent line is the one that just touches one point in the curve. Secant line goes between 2 points, right? Typically. All right. So that is your sine and cosine. And then we have some funky stuff here. So here's some, we'll just try one more and we'll stop because I also want to give you a chance to talk about the programming piece that we're going to talk about because I did some polls with you guys last week, right? And we kind of had some results. I can tell you what they are after this, right? So let's take a look at this one. This is interesting. It's a big one, right? Or looks big, right? Now, remember, we're trying to accumulate all the rules we're using here, right, to make this all work, okay? So let's do this big one, okay? So we're going to get rid of this one, and we'll just X out this one, and we'll put that one in there. So x to the 5, we'll write this out, x to the 5, right? And then times sine x, sine of x, there it is, right? Minus 3 times cos of x, there we go, plus a scalar of 10x, or a translation of 10x. There you go. That's wow, what a great graph that is, right? Lines all over the place, right? All right, so what do we do here? Any suggestions on how we handle this one? Come on, guys. I want you to help me out. I don't know what to do, right? We have some sine and cosine, but we also have some rules we have to follow. What's the first rule? What do you see here that I must do? I have parts. I have different terms, right? So when I say terms, just so we're clear on the syntax, the naming convention we're using, right? The first term is this one, okay? Do I have to do anything with the first term? Quotient, oh, sorry, a product rule, right? What about this one? Do I have to do anything on this one? Constant rule, maybe I can use constant rule there, right? And is there anything I need to do on this one? No, this is pretty simple, right? So let's do the first one first, the most complex one. So derivative of the first, right, times the second, times the second, right? So it's cosine of x. Oh, so it's times the second, sine of x, plus the derivative of the second, cos x, times the first. So 5x, and I'll put this in brackets, 5x to the 4. We leave it intact, right? Oops. X to the 5. I'll be okay. X to the 5. X to the 5. Whoop, there we go. So now the reason why this doesn't work, because it's listening, it's trying to figure this out, right? It's trying to know what I'm doing here, right? You have to make it. This graphing program needs to know that one term multiplies by the other term for it to work out. So this is we just handled this term here. Remember I talked about time on an exam? This is why, right? Because you have this little complicated thing with sine and cosine. Okay, let's do the next part. So the first term, the second term, minus, right? Let's leave the second term intact, minus. We take the 3 out, right? Because that's the constant rule. And cosine x is negative sine x, right? So we put that negative sine x aside, right? And then plus 10. And that's your first derivative. It looks wacky wild, eh? This crazy one. Yeah, it first works, right? Now, Hercules is going to say, please simplify. I think it's okay to simplify to this level. If you multiply minus 3 by minus, you get a positive. So this would be the most I'd probably want you to do, right? Does that make sense? That makes sense, right? Like you'd want to do some minimum.
Second term does not get reduced any further.
This second second term, why would you reduce it? This is leave it alone. Brackets away, but who cares, right? If I saw it like this or very close to it, I'd be fine. Now, the second derivative of this would be a big page of stuff because why? You have 3 terms here, right? Or 4 terms now. Notice that 3 terms went to 4 terms, right? Here's your first term. I need to do product rule. Here's your second term. I need to do product rule. Here's your third term. I don't need to do product rule here, all right? But it flips again. It goes from sine to cosine again, and you take out the 3, right? And then so you get this back again, right? And then this one disappears. This plus 10 goes to 0, right? So that is, you need 1 term, the second term, and the third term. You don't have to worry about this one, okay? Are we good? Do you understand how to do stuff with sine and cosine? By the way, there's going to be other more complex stuff than this that we're going to try and tackle at the lab. But if you notice, this would be something where we would do a little bit more. I'm not going to do this one right now, just from a time perspective. We're running out of time, right? But if you notice that I would use the quotient rule here, right? 1 plus sine x over x plus cos x. I would use the quotient rule. This would be the first term up here times the second term, right? I would do that div top times bottom minus div the bottom times the top all over the bottom squared, right? And that would be the quotient rule for this one. Okay, the rest, if you notice, is a bunch of problems and examples that we're going to work on in the lab. So please join me in the lab in C401, I believe, right? I'm just going to save this one. One thing I wanted to talk about is what we decided last time, which was we had this little, I did this little poll, and we talked about which one did you want? Did you want Unity or whatever? And the winner, guys, like I thought would be when I added it all up, was Unity. So we're going to be using Unity with C#. That's the announcement, right? It won out in every class. Every class had some portion of Unity, right? And only one class had no one had JavaScript. None of them had JavaScript. C++, there was a couple of different ones. One of them had Unreal, and we used the other framework for SFML, right? And the problem with this is there's just more Unity than anything else. So we're going to be using Unity. That's what you guys mostly want, okay? The great thing about this is if we use, it doesn't matter which programming language and framework we use because the functions we're going to make are all very basic, right? So nothing to worry about. All right, that's it for today. Let's meet in C401 to do the lab. For those people who are with me. Otherwise, Thursday, I'll see you at 3:30 in the lab for those people.